Now these two questions again are based on the polymerization reaction. A compound like this is considered. In presence of OH minus, a base, X is produced. And once this X is formed, this undergoes polymerization reaction, leading to the formation of Y. The question is, what are X and Y? Now, whenever a ring structure is considered, now in the first reaction, in presence of OH minus, we notice this ring structure breaks down. It breaks at this point. So, in presence of OH minus, this ring compound breaks into a linear compound CO, here CH2, CH2O. So, X that is formed is due to the breaking of this ring structure at this point. So, we get CO, CH2, CH2O. This is X. And a large number of these molecules of X, which may be considered as, say, a monomer. These undergo further polymerization, leading to a linear molecule like this. Of course, you can notice in this arrangement, whether it is X or Y, we find only thing is in the first step, the ring structure collapses to form a linear structure. In the formation of this, we notice there is no elimination. Similarly, this acts as X, acts as the monomer, and it undergoes polymerization reaction, leads to the production of this polymer Y. So, X is this particular linear species which undergoes polymerization to give Y. Now, in questions of this type, we notice 2 points. One is, if you consider a ring structure, this may undergo rupture at a particular point. Because of this, the ring structure is converted into a linear species, which, acting as a monomer, will undergo polymerization to give the corresponding polymer. Or it is also possible to think of a linear molecule undergoing polymerization reaction, leading to the formation of a polymer in which a ring structure is possible. Consider question number 4. Here we consider a ketone, CO group, methyl group on one side and vinyl group on the other side. So, methyl vinyl ketone. This undergoes polymerization reaction. It gives A, but this A in presence of OH minus forms B. So, here ring gets ruptured, and here in this problem, closure of this to form a ring structure. Now let us consider if this molecule undergoes, this ketone undergoes polymerization reaction, we find this bond breaks up. So CH2, here single bond, CH, CH2, CO, CH3 I have written here, another CH2, CHO3 like that. So this is A, bond breaking, double bond breaking, and in order to show that ring closure takes place, I have written like this. So this leads to single bond CH2, CH, COCH3, but here there should be another valency which is satisfied by another molecule of this ketone by breaking this particular double bond, and so this continues to give a structure like this, A. All right. What happens to A in presence of OH minus? In presence of a base, ring closure takes place, namely from this CO and adjacent CH3 here, a water molecule will be removed and one hydrogen is attached to this CH. And because of that, between these two carbons, a double bond is formed. Here you will have a CH. So this process of elimination of water molecule from adjacent CO and CH3 groups, ring closure takes place with the production of a double bond here and formation of a CH group here, and so from A to B we notice ring closure takes place. So if you consider and compare these two questions, question number 3 involves the rupture of the ring structure so that a linear species is formed which leads to the production of a linear polymer. But in the case of question number 4, from a linear molecule like this ketone which undergoes polymerization reaction, a monomer of this type is produced, and since there is the removal of water molecule, it is a condensation reaction, whereas this is the addition reaction. And here, because of this elimination of water molecule from these adjacent CO and CH3, you remove water molecule, leaving C double bond CH here. Out of 3 hydrogens, 2 are utilized in the removal of water and 1 H is left out here. So you get a ring closure. A molecule like this is being produced. So A and B, you can notice B because of ring closure you get a polymer having the rings. So from a linear molecule you get rings, but in question number 3 from a ring you get a linear molecule. So both of them are possible.